Okay, here's the A problems for 6 through 11. 6a, it says which statement correctly compares the function shown on this graph with the function 6x y equals 6x minus 1. Well, I wrote 6x minus 1 here. On the graph, we have to find out the information, the slope and the y-intercept. The y-intercept is 6 right here. The slope, this graph goes by 2, so I counted up 2, 4, 6, 8, 10. And over 2, 10 over 2 gives you a slope of 5. So that's the equation for this. So the answer is the graph has a smaller rate of change of 5 because this is 6, and it has a lower starting point. -6 is lower than -1. So that was the answer for that. 7a. Let's go back over this way. Car A is traveling east at a steady speed of 45 miles per hour. After 2 hours, it is 100 miles east of Johnstown. Car B is traveling east on the same road. Its distance east of Johnstown is represented by the graph. Where were the two cars in relation to each other when they began traveling? Remember, they're only asking us here to find the y-intercept. They're talking about where the two cars began. We can look at the graph to find out this easily about car B. The y-intercept is 20, so it was 20 miles out. There's a little line representing car B. Car A, we have to do a little more figuring because it says it's 100 miles east of Johnstown after 2 hours, and it's going 45 miles per hour. So I took away 45 twice to represent the 2 hours, so that means it's 10 miles east. So your answer is car B is 10 miles east of car A. 8a, 2 hot air balloons are traveling along the same path away from a town, beginning from different locations at the same time. Henry's balloon begins 15 miles from the town and is 31 miles from the town after 2 hours. The distance of Tasha's balloon from the town is represented by the function y is equal to 5x plus 25. So we see Tasha's speed for a balloon is 5 miles per hour. It was 25 miles out. We have to do a little figuring for Henry, though. His was 15 miles out, so the y-intercept is 0, 15. That's a point we can use. And after 2 hours, it was 31 miles out, so that's the other point we can use. And we use those 2 points to find the slope, which is 8, and we can write our equation, y is equal to 8x plus 15. So therefore, Tasha's balloon was further out. It was 25. Henry's was 15, but Henry's I put ballroom. I don't know where in the world I got that. Balloon. That R just changes the whole word, doesn't it? Henry's balloon was faster at 8 miles per hour, and Tasha's 5 miles per hour. Okay. 9a. Identify the slope and the y-intercept. Just look at it and see what it is. mx plus b. M is your slope. B is your y-intercept. Slope is 3, the y-intercept is -6. 10a, bird flies south. Its distance from the nest as a function of time is modeled by y is equal to 20x plus 1, which statement describes the function. So this is asking you, is this linear or nonlinear? It's linear because the highest power of x is just 1. Remember, the ones that are not linear look like y is equal to 2x squared plus 1. The x has a power other than 1. It could be x to the third, x to the fourth, or even it could be where x is your exponent. That is not linear either. These are not linear. But if x has a power of 1, it is linear. And then table A for 11a. Which table shows a linear function? It is table A because it has a constant rate of change for the x's and the y's. The x's go up by 1, the y's go down by 3. All the x's go up by 1 in all of the examples, but the y's are not constant. This goes down 2, up 1, down 2. This goes up 2, up 3, up 3. This goes down 1, down 2, down 3. Okay, hope that helps, and I'll see you Monday.